Hello and welcome to the first of these talking mark schemes for the AS exam style questions organic reaction mechanisms resource. So these videos are designed to help you understand the step-by-step process that you need to take when answering a question based around mechanistic organic chemistry. So with that in mind, let's get on with the first question. So the first question says both ethane and ethene can be used to produce chloroethane. So that is this molecule here. And the first part of the question asks you to state the reagent and the condition that can be used to make chloroethane from ethane. And that is worth 2 marks. So you get 1 mark for the reagent and 1 mark for the condition. So to produce a halogenoalkane from an alkane, you need to react it with the halogen itself. So the reagent here would be chlorine, or Cl2, and the condition would be UV light. And so the reason you need to use UV light is because when you have a chlorine molecule, so this is what a chlorine molecule looks like. When you have one of these molecules, if you shine UV light onto the bond, it causes a homolytic fission to occur. So I'm going to represent this using the single-headed curly arrows. So remember, a curly arrow represents the movement of electrons. So if it's got a double head like that, it means it's the movement of a pair of electrons, whereas if it's got a single head or fish hook like these, it means it's the movement of 1 electron. So you can see shining UV light onto this bond breaks it, and you form 2 chlorine radicals. So these 2 chlorine radicals can then start to react through a free radical substitution. So that leads on quite nicely to the next question. What type of reaction mechanism does this occur by? Now this is also worth 2 marks, so the correct answer is it is a free radical substitution. So let's think about why it's called a free radical substitution. So it's a radical substitution because you can see here we form 2 radicals, and this is the initiation step of the reaction. And so these radicals will then go on to react with the alkane in a substitution reaction. So that's where we get the substitution from. Because if you look at the equation of this reaction, you'll have C2H6 plus Cl2 will form C2H5Cl plus HCl. So what you've effectively done is you've substituted one of the hydrogens in the ethane for a chlorine atom, so it's a substitution reaction. So that's why we call this a free radical substitution. Now for the distribution of marks, you get 1 mark for saying that the reagent is chlorine or Cl2, you get a mark for saying the condition is UV light or sunlight, you get a mark for saying it's a substitution reaction, and you get a mark for saying it's a radical. So if you said radical something else, then you would still get 1 mark out of 2. And if you were to say it was a substitution, you'd still get a mark. But to get both marks, you need to say it's a radical substitution. It doesn't matter if you don't include the word free. Okay? So moving on from there, you're asked to state the reagent used to make chloroethane from ethene. So to make chloroethane from ethene, you need to use hydrogen chloride. So the answer there is hydrogen chloride, or HCl. Yeah? If you write hydrochloric acid or HCl aqueous, so if you were to write either of these 2, you would not get the marks, okay? So that is technically not the correct answer, because this is a reaction that occurs in the gas phase, and as such you do not have any hydrochloric acid or aqueous reactants in the mixture. Okay, so now the best part of it all, the mechanism. So you're asked to draw a mechanism showing how chloroethane is formed from ethene, and you need to show all of your relevant dipoles and charges in this reaction. So let's draw our ethene. And let's draw our hydrogen chloride. Okay, so there are your 2 reactants. Now, Let's first of all think about the dipoles and what parts of each molecule can react. So for HCl, because chlorine is more electronegative than hydrogen, you have a delta minus charge on the chlorine and a delta positive charge on the hydrogen. So the electrons are going to be lying closer to the chlorine atom in this HCl bond. Now in this molecule, in the ethene, you will see that there is a region of high electron density in this double bond, or pi bond as it's also known as. So there's a region of high electron density and a delta positive charge here. So what's likely to react? Well, you're going to get a pair of electrons from the double bond reacting with the hydrogen in the HCl. Okay, so the electron pair in the pi bond is attracted to this slightly positive hydrogen and the double bond is broken. So this curly arrow here represents movement of electrons, and the movement of electrons is showing that a new bond is now forming between one of these carbon atoms and the hydrogen atom. Okay, so but because of this, the bond between hydrogen and chloride and the chlorine, breaks. So that's what that curly arrow represents. The electrons from the HCl bond are now going on to the chlorine. So what happens now is we've formed these two products. So we've got the H, and the H there, so that's your new hydrogen there. Got an H there and an H there. You also have a Cl there. So we need to include all relevant dipoles and charges. So because you've had a pair of electrons move onto this chlorine, it's now a chloride ion. Okay, so that's now got a negative charge. And this carbon here has a positive charge because it's now only bonded to 3 different atoms and it's lost that pair of electrons in the pi bond. Yeah? So from there, what you will see happen is that this negatively charged chloride ion is now attracted to the carbocation, and you get a bond forming between those two, and then finishing this off, your final products are, well, your final product rather, there's only one, is just this, so chloroethane. Okay, and so now for the distribution of marks there, you get 1 mark for saying it's hydrogen chloride. You get 1 mark for all of the charges and dipoles being correct, so 1 mark for charges and dipoles correct. You get 1 mark for this arrow here, and you get 1 mark for these arrows here. Okay, so 1 mark for both these arrows, yeah? So you get a mark for those curly arrows in the first step, curly arrow in the second step, and for the charges and the dipoles being correct. So from there, there's your 3 marks. And that's the end of the first question.